towards supply chain transparency, or is it still vertical based?
Still vertical.
That's right. I asked them to turn this up loud for two reasons. One, I think I'm damn funny. And two, I've got a lot of talks to give today. And so I'm going to try to keep this as amplified as possible. Cover your ears if this is painful, okay? Especially Martha in the front row. So what are we going to talk about today? We are going to talk about S-bomb and possibly confectionery. Who knows what an S-bomb is? All right. The CISA folks can't, that's cheating. Someone say out loud what this acronym stands for. It's a software bill of materials. And we're going to talk about what it is and why it's important. While you're still here, before you run away, what are the key takeaways that I want you to remember? One, this is a core concept that is reasonably understood today. This is not completely mature tech, but it is pretty darn mature. And that means everyone can start today. I feel you should be able to take away what I'm telling you about S-bomb and figure things out. You can start doing it in your organization, and more importantly, you can start telling other people to do it. It's always a lot easier to say you do it, right? We're shifting into how we think about data. I'm not going to get too deep in the weeds on data. And what I do want to also say is there are a bunch of efforts happening right now, both outside of government, but more importantly, since we're under the giant eagle, inside government right here at CISA to shape the future of this. And we want your help. All right. Well, that's weird. There we go. Okay. What do we talk about before lunch? Here's another key takeaway. I want everyone to think about the software that's on your network. I want everyone to think about the software that your organization uses, and maybe the software that the person in the desk next to you writes. And I have a core point that I think you'll be able to remember, which is it is bananas that we don't know what's in our software. Right? How on earth have we gotten this far without having not necessarily a standard, not a regulation, but just simple visibility about what's in our software? And that's what we're going to talk about today. So let's talk about, again, you can tell I'm a little hungry. So again, if you go buy a Twinkie, sorry, I'm pushing the wrong button, it's going to come with a list of ingredients. So, and again, it's bananas that we know more about what's in a Twinkie than we do what's in our critical infrastructure, what's in our hospitals, what's in our national security networks. So the goal here is to do that. But I also want to acknowledge the limits of transparency. The SB in S-bomb does not stand for silver bullet. We're not trying to solve everything. So what's this list of ingredients not do? This list of ingredients by itself will not prevent someone in your family from having something that they're very allergic to. List of ingredients by itself won't keep me on my distant memory of a 24 diet. It won't enable, or it won't give me a plant-based diet or a religious diet or things like that. But, so we acknowledge the limits, but here's why we do it anyway. Because you can't do any of those things without that list of ingredients. And so as you think about software transparency, remember, it is a starting point. It is an enabler. It is necessary, but not sufficient. Why? Because we're talking supply chains. Supply chains are scary. We all have them. And they're all being attacked. Software is eating the world. We know this. And we also know that software has a supply chain. Software is not hewn out of marble by monks on Greek islands. No, it's assembled, right? You take a thing and you put it in another thing. And you've got your Java framework, or you've got your open source that you're collecting, or, you know, let's be honest, Stack Overflow, just copy paste. Yeah. So we all sort of assemble our software, and a lot of that is, of course, open software. Some of that software has vulnerabilities, and in fact, quite a few vulnerabilities, and about 30,000 new ones every year. Let's step away from security for a second. Who knows if their product actually follows and complies with open source licensing rules? This man does. Who thinks that if GPL ever did an audit of their company, they would actually have to pay some money? Right? This is something that Americans aren't very good at. Europeans are pretty good about knowing their open source risks. And of course, when we're talking about OSS dependencies, we have to put up Randall Munroe, where we don't have visibility and we can't tell anyone what to do, right? Open source maintainers look downstream at the people who use their open source work and say, I am not your supply chain. Actually, what they usually say is, I am not your expletive supply chain. And of course, not everything in your supply chain is actually fresh and up to date. Some of it's expired and starting to smell. Y'all remember Avanti? Do you see how old these components are? This is publicly discovered the first time anyone actually went looking. 14 years, 15 years, 22 years. This is insane. And this isn't just general risk. We're starting to actually have to worry about geopolitical risk. Because the people that are hacking your network may not care about your network. They may want to compromise something that has a much bigger bang. Critical infrastructure, espionage, things like that. There are a number of frameworks out there for thinking about supply chain attacks. This is from the intelligence community. This is from Google. It's very informative to look at the different approaches to graphic design. Why are there supply chain attacks? I'd argue it's actually a good thing. Maybe, just maybe, we're collectively getting a little better at writing software. And so that means that the supply chain is the soft underbelly of our digital infrastructure. And in case you're wondering, yes, that is my excuse of putting my dog in the CISA booth presentation in the middle of RSA. That's Hamon, and he's a very good boy. Okay, Alan, you've been talking about SBOM for a while now. You're very engaging, but you haven't taught us anything. Okay, you want to know what an SBOM is? This is an SBOM. It's not that complicated. This is my software. This software uses this software. This software, in turn, uses this software. It's dependencies all the way down. You know this. This is baked into your GitHub tools. This is baked into your GitLab tools. For each of these components, there's a lot of information we may want about different types of risk, but the basics aren't that complicated. Who's the supplier? Right? Is it open source? Is it proprietary? If it's proprietary, who made it? What's the component? What's the version, right? Is this the freshest and healthiest, or is this something that has been stale? And then we need identifiers. And next year I'll come and talk about software identifiers. It's a hard problem, but we at CISA are tackling it head on. Why do you want SBOM? Depends on what you do. Who makes software? Anyone here make software? All right. Who chooses software? Who buys software or selects software? We got a couple here. Who operates software? Who's in the SOC or who's defending their network? We got a couple here. Great. One last question. How many of you do all three of those? Right? At CISA, we spend a lot of time doing all three. And you can't say that you have a secure process if you don't have a secure development process. Excuse me for one moment. Sorry. All right. If you choose software, you need to start paying attention to your supply chain. Hey, where's this coming from? What about the technical debt, right? Again, not even a security concern. How much of this is just wildly out of date or no longer supported, end of life? And then once it's running on your network, how do you respond to the next log4j. I'm sorry, the next XZ. I'm sorry, the next libwebp. I'm sorry, the next, right? Does anyone believe that there isn't going to be another front page vulnerability before 2024 is over? Right? We know it's going to happen. And in 2024, if you can't look at your network and automatically figure out, using tools, am I affected? I'm going to say something that is going to make my boss back there pissed off at me. I'm going to say your organization is bad at security, because we have the tools today to take SBOM data, put it in a pile, and then do some quick and dirty scans to at least figure things out. We need to talk about the life cycle of software, because there's diversity, right? Some of us spend our time in code. Not me. I was actually never very good at writing code. I liked it. It was fun. I just always saw other people do it better. Some people build software. You've got your DevOps pipeline. You've got your CI/CD. I think there are like 7 people in the world that understand how compilers work, but we all use them. And this might be the source of truth, because your compiler is doing some things, so why not go and capture all the dependencies when you're creating your software? Well, why not? Well, you can say, listen, Alan, I've got some software on my network. It's old. I can't turn it off. It's really important to me. Well, that's okay, because there's a whole set of tools called binary analysis tools. Unfortunately, there's only really one open source one, but there are a bunch of proprietary ones that you can say, this blinking box keeps the whole hospital running. We should know what's in it. And you can do binary analysis on the image for that. Or you can ask your supplier to do that. How do we implement this? We implement it at scale with machine readability, supporting automation. If you're doing anything in your security team that isn't inherently built for automation, please stop, right? Everything we do should focus on automation. The good news is that there are 2 data formats out there. They're both open source. CycloneDX comes from OWASP. SPDX comes from the Linux Foundation. They're both amazing communities. They both have active development. They're both coming up with new versions. There's a little bit of a bad news, though. They kind of hate each other. And that's okay, because the US government is not going to pick a winner or a loser in a standards fight. We have a really bad track record of doing that, right? We're not the winner. We're not the decider in a standards battle. But one of the things we have done, and the next talk, I think, Mark, you're going to talk a little more about this, is CISA with our partners at DHS and our partners at OpenSF have created a translator tool. So guess what? Take either data format, put them together. It's not a big deal anymore. Depth matters, right? You can say I want my top level SBOM. That'll help you a little bit. But if you're looking for your log4j, it's going to be all the way at the bottom. So can we do this today? A little while ago, this was a chicken and egg problem. No one was asking for this data, so no one was providing it. No one was providing it, so no one was asking for it. But I'd argue that, heck yeah, we can do this today. Financial services, healthcare, energy, automotive, and these are the hard sectors, are implementing SBOM. Cloud native is like way past this. This is something that just is an automatic part of how they think about software, and it's pretty straightforward. Now, I love this quote. I'm not going to tell you who said it, but it's from the head of product security of one of the largest software manufacturers on the planet. And he said, Alan, we like this. We want this. Actually, we need this. But let's be honest, we're going to do it when someone makes us. Enter your friends in the US government. Back in 2021, the White House issued the executive order that said, we should have better software. This is a great idea, right? I think everyone agreed we should have better software. And the president began this document in the introduction, which is a line that I love, which is the trust we place in our digital infrastructure should be proportional to how trustworthy and how transparent that infrastructure is. So the White House laid out a requirement that sooner rather than later, we are going to be requiring an SBOM for everything the U.S. government buys. And I'll give you guys a hint. We buy a lot of things. Not just software, but things with software. So I'm not going to walk you through the process. There's a lot of fun details here. One of the things that we collectively have had to think about in the government is, what do we mean by SBOM? Right? We can't just say have an SBOM and then have you come up and say, well, this looks like an SBOM, and you're like, no, that's a fish. That's not an SBOM. So we defined what are called the minimum. The downside of talking nonstop for several days. We defined the minimum elements. It said to qualify as an SBOM, just for the U.S. government purposes, you got to have these properties, including who wrote the data, right? Did the data come from you? Did it come from your supplier? Did it come from a tool? And so on. CISA is going to be updating these minimum elements very soon. So if you're in the SBOM biz, you should watch us, because we're going to tell a lot of people that we're doing it. And in the meantime, look at this 2021 document and say, oh yeah, this is what we should update. It's also being required by regulators. If you want to sell a new medical device today, before the FDA will let you start selling a blinking box that's going to keep someone alive, you have to give the FDA an SBOM. And they have pretty strict requirements. So other regulators are starting to look at it across healthcare, across other regulated sectors, across standards. We're also vaguely aware that we, the United States, are not the only country in the world, and that to do security well, we need to partner closely with our allies, our peer cybersecurity agencies. And so CISA has set up a SBOM working group. It's not the senior people, right? We don't want important people to give speeches. We want working engineers to figure out, how do we align this? And one of our core goals, of course, is to say, let's make sure there isn't a European SBOM and a Japanese SBOM and a medical device SBOM. Again, because we all use the same software, so we're working hard to harmonize on that front. So, what's the state of SBOM today? I think we're doing great, but there's a lot more to do. We've reached the plateau that most folks in the software world are aware they need to think about their supply chains. What we do need to do is now drill down on some of the fun engineering. I'm a failed engineer, about interoperability and integration. So again, remember that software transparency won't solve all of our supply chain and vulnerability management issues, but it's going to be very difficult to make real progress if we don't have transparency. One of the next steps we're working on is, what do I do with all these SBOMs? There are a few tools today. As people start asking for them, including us in the US government, there are going to be more tomorrow, both open source and proprietary. All right. I want to acknowledge there's a fun little problem for those of you who love software infrastructure, which is we have a naming problem. Now, there are only two hard things in computer science: software identification, validation, and naming things, and off by one errors. So we have made some progress on proposing some solutions coming out very soon. What else is next? Hey, software runs on hardware. You can't take a hash of a DIMM. You can't take a hash of an LTE chip. So how do we actually know what's in our hardware and whether it's trustworthy? And there's some fun work, including a great side workshop that's happening this afternoon that is asking the question, what does SBOM mean for AI? Transparency is very similar, right? AI is software, so you need the SBOM, but AI is more than software. So we need to think about that as well. There's some fun work for those of you who care about cryptography. Cryptographic bill of materials, right? If we're looking forward to post-quantum encryption, well, the first step is, what do I have today? And that means starting to be able to document and communicate what are my cryptographic algorithms, where's my key material, and so on. All right. I got a few minutes for questions, but again, the takeaways are the important thing is everyone should start today. You've now all heard of SBOM, if you haven't before, and you should be talking to the folks in your world who care about supply chain, who care about compliance, who care about vulnerabilities, who build software, who are in the SOC. This layer of data is going to transform a number of marketplaces, and we want to help here at CISA. And if you're interested in learning more, we've got a stack of business cards. We have public meetings. Anyone can join. We have folks join. It's 11 a.m. on Mondays, Eastern time. But there's a wonderful guy named Tomo-san. He's from the Japanese National CERT. Guy calls in at 1 a.m. his time to help our global effort. We're looking to, one, help spread the word about the value of SBOM, and two, shape the future. What are the implementation problems that you face? Because we can't solve them at CISA. What we can do is work with you and other experts to build these solutions. So that's what I have to say. I have some SBOM stickers, because who doesn't love stickers? And very happy to chat more about SBOM. Thanks so much for your time. Have a fantastic con. If you want to know more about CISA, my colleagues are amazing. This is the best place in government to work, and I'd argue one of the most exciting places in all of cybersecurity to be working today. Thanks again, guys. Anyone have questions? Ran over a little bit.